Okay, mechanical systems. Our third topic is what's called the spring force, and it's a pretty, it's unlike friction that applies all the time and normal force that applies all the time. Spring force or gravity that applies all the force. Spring force obviously only applies when you're working with a spring or any elastic object. So, I mean, elastic band itself, for example, would have a spring force. So Robert Hooke developed an equation to investigate, so this guy here, way back in 1790, and he just found an equation that relates springs and how much force you need to stretch or squish them, okay? And his discovery, this is one way you could say it. The more force you apply to a spring, whether to stretch or compress, will result in a proportionately more stretch or compression. Proportionally means like, if I apply 100 newtons, I should get and then I apply 200 newtons, so I double my force, I'll get double the stretch or double the squish. Okay, on a spring. So imagine a spring, you could pull it, stretch it, or squish it. Or as he put it, as the extension, so the force. So there's an equation for spring force. So F is the amount of force that you apply to the spring. So F is always force, right? In this case, it's a force applied to a spring. And you might be squishing squishing a spring, or you might be stretching a spring. Stretching a spring. X is, in this case, doesn't really fit because we always think of lengths or distances as D, but X is the amount the spring is stretched or squished. So it's a meters, it's a length, okay? So if the spring was originally 1 meter long and you stretched it so that it was 150 meters long, or 1.5 meters long, the X value would be 0.5. It's how much change there is. Okay, so it's the difference between a stretched or squished length and the natural length of that spring. And then K is this number. It's a measure of stiffness of the spring. So a high value for K means a really stiff spring. A low value, like say 2 or 3, might be a slinky. And its unit is newtons per meter. So K is the amount of force required to stretch a spring by 1 meter. So if we're doing, here's a question solving for K. Ferd caught a 5.5 kilogram fish, and he hangs it from the spring here. When the fish is hung from the spring is stretched by 60 centimeters, or 0.6 meters, from its original length. So we don't even know the original length, we just know the change. We're given the change here. We want to find the spring constant. So what we know then, we know that X is 0.6, and we know the mass applied to the spring is 5.5. But the equation says we have to know force. Well, when you're hanging something from a spring, the force is the force of gravity. Okay? You're not pulling on it, so to speak. Just the fish is sitting there, and the fish's mass is pulling down. The fish's mass is causing the stretch. So it's gravity. That's actually, in this case, the spring force. The force applied to the spring. So we're looking for the K value. So mg, that slash is me saying divide. So it's going to be the mass. So basically, this is the equation. Divide both sides by x is what I'm doing right here. Now I have mass times 9.8 divided by 0.6. So that spring constant is 90 newtons per meter, which is a pretty typical number, I think. Like usually between, say, like I say, a slinky might be 2 newtons per meter, but a truck spring would be in the thousands. So some little spring like that, 90 probably makes sense. And notice the units, newtons per meter. It's the number. If I wanted to stretch this spring by a whole meter, you would apply 90 newtons. That's what that means. If in this case we only stretched it by 0.6 meters, and the force we applied was about 55 newtons, right? Another one. What's this one? The shocks in a pickup truck are made up of 4 springs each with a spring constant of 20,000 newtons per meter. Okay? But we have 4 springs. Determine how much the springs will be compressed if you sat a 1,400 kilogram piano, and let's include the 200 kilogram combined mass of piano player and dog. So there's 1,400 kilogram piano plus a dog and a piano player. So we're adding 1,600 kilograms to this thing. Again, it's gravity that's causing the spring force this time. We'll say the constant is just 4 times, because we want to know how much each spring is compressed. So each spring, like the total spring constant then will be 4 times 20. Okay? It's like, another way you could do this question is to break up the mass into the amount of mass per spring. You know what I mean? So you could do it that way. But I'm just saying, let's look at the whole thing and say we've got a combined spring constant of 80,000 newtons. And there's the mass being placed on it. And what's the x? How much is that, the back of that truck, going to squish? So the force is mass times 9.8. Spring force is k times x. So you can equate those two. So anytime you're looking at something where gravity's causing the stretch or the squish, you just say kx equals mg. Spring force equals gravity. This time we're looking for the x, the amount of stretch or squish, sorry. So you just divide both sides by k. So 1600. 1600 times 9.8 divided by 80,000. I wonder if that's a good number, if I didn't mess that up. This number might be wrong. 1600 times 9.8 divided by 80,000. Let's just check it quick. 1600 times 9.8. Sorry, I make a lot of mistakes. Times 9.8 divided by 80,000 is equal to 20 centimeters. 0.196, I'll say that's 20 centimeters. Change that. 0.2 meters. Okay? So that means when everything's in there, I'm going to guess it'd be something bigger. I just made up these numbers, so I'm going to guess it'd be something bigger than 20 centimeters. You'd sink when you sat a piano in the back, but whatever. Anyway, so that's the springs. That's how they work, and the questions and everything. So there's a little lab. It's pretty easy that I want you to do with your group and submit one per group. So, but you all have to be working together on it. So everyone has to be back there working on it. So if not everybody's here today or the day you plan on doing that one, just do it another day, or the person who's missing maybe joins with someone else. And then there's a couple questions similar to these ones to try. Okay, so that's it for springs. That's the end of your assignment too. So the spring little lab and the spring questions are the last part of the next assignment.